Hello everyone, welcome to the series of O-Level Mathematics Class 9-1 Cambridge IGCSE syllabus. In today's lecture, we will see composite functions. In our previous lectures, we already see what are functions, what are inverse functions, how to represent them, how to solve them, how to write them, and we did exercises of these concepts. And for the exercises, we used Cole's books, exercise 21A and 21B. Today we are going to start exercise 21.3 of chapter 21 of Coyle's book, which are composite functions. And today we see the concept of composite functions, what they are, how to represent them. Okay, so let's see what is meant by composite functions. So to see the concept of composite function, let's see and consider this scenario that let's suppose we have two functions, right? So let's suppose we are given two functions. Okay, the first function is f of x, which is 2x, and the second function is g of x, which is x minus 3. And we are giving the value of x. So x are 2, 3, 5, and minus 3, right? So what we did first, let's put these inputs in this function f of x. So first put in place of x2. So what we got, 2 in bracket 2, 2 into 2 is 4. Then f in place of x, we write 3. So 2 into 3 is 6. Then f into 5, 2 into 5 is 10. And the last one is f minus 3. So 2 into minus 3 is minus 6. Now, in g of x, we are not going to put this value of x, but what we are doing, we have to put the value of these that we get from f. So here in g of x, I put instead of, so here in place of x, I am putting 4. So what I get as an answer of f, I am putting it into g of x. So g of x is the g of 4. So 4 in place of x, I write 4. 4 minus 3 is 1. Right? Then g, now in place of x, I am putting this 6, what I get from f. So 6 minus 3 is 3. Again, I am putting in g is 10, and this 10 I got from f. So 10 minus 3, it is 7. And at last, I am putting minus 6 in g that I got from f. So minus 6 minus 3 is equals minus 9. So actually what I did, I put x, these x's that I have given in f, and whatever I got from f, I put this in g. So you can see that actually instead of one function, we are now have two functions, and these two functions are behaving like this, that we put input in f, we put our input in here x, and we got some value, right? Like here, I put 2, 3, 5, minus 3, and I got some values. I put these values and I got these 4, 6, 10, and minus 6. And then I evaluate G on this value. So actually this concept is called composition, that we compose actually two functions. And how we composed it? So composition, the concept of composition is really easy. And the concept is that in composition, we have two functions. So in composition, we have two functions. Okay. And how we connect these two functions? So in composition we have two functions, and the main thing is how to connect these two functions. How to connect these two functions. So, how to connect these two functions. So, and we see how we connect these two functions. We put input. So, the answer is we put input in F and got output. And then we put this output in G and got new output. So just this is the main crux to make a composition of two functions, right? So this is the concept of composition. Okay, now let's see an example about the composition of functions. So suppose we are given two function h of x, which is x square, and k of x, which is x plus 4. We have to find in part A kh3. Okay, so we have to find kh of 3. So you see that here they are giving us the composition. Why? Because they are using both functions h and k. It means it is a composition. But how to we evaluate this composition? So we read it from right to left to right. We read it like this. So when we read it from left to right, so first thing is what we got is this 3 with h. So what we have to evaluate first? H of 3. So h of 3. And what is h of 3? So h of x is x square. It means h of 3 is 3 square. So it is 9. Okay. So now we got so k as it is because we didn't do about k now. And h of 3 we found 9. So actually now we have to find k of 9. So what is k? K of x we are given x plus 4. Now we have to find k of 9. So 9 plus 4, it is 13. So part A is done. So what we are saying that k of h of 3 is 30. Okay, let's do part B. So in part B, we have k h minus 2, right? So again, we have to read it from right to left. So from right to left, we have minus 2 and h. So first we have to do h of minus 2. So h of x is x square and h of minus 2 is minus 2 square. So minus 2 square is 4. Now, since we found this h of minus 2, we have to put this value in k. So k of x is actually x plus 4. So k of what we have to do? 4. So 4 plus 4 is 8. Okay. So at the end, we got k h of minus 2 is 8. Now, in part C, there is a little difference. And the difference is now they are asking me hk5. So again, we know that we read it like right to left. So what we have first, we use k of x first because we have to find k of 5. So k of x is x plus 4. So k of 5 is 5 plus 4, which is 9. Then we have to put this k of 5, right? We found out k of 5. Now we put it in h. So h of x is x square. So h of 9 is 9 square, which is 80. So that is how you can evaluate the composition of function. An example is done. So here is another example. And this example is important, and in papers mostly this examples will occur, this type of example is occurs. So there are two types of actually questions that can occur and come in exam. The first one, as a first example we did, to evaluate the value of composition function. The composition function are given in the example and the value is also given, and we have to just put the values. Here is another example, and this is the most important example. And this type of example, the questions mostly occurs in the exams. And let's see what is this example and how to solve it. So in this example, we have given two function f of x, which is 2x, and g of x, which is x minus 3. So in composition of function, we always have given two function, because composition means to compose things. So it means we always have more than one things. In this type of question, we are always given two function. So here also we have two functions, f of x is 2f(x) and g of x is x minus 3. Now we have to find f of g of x. So here you can see there is no values of x they are given. They are just giving us two functions. This is the first function, this is second function, and in part A they are just want to find from us that find f of g of x. Okay, so how to solve or how to find this f of g of x? So first of all, what is g of x? Always we know that for the composition of function, we have to read this is from right to left. So when you read it from right to left, you see that we have g of x first. So write g of x first. So g of x is x minus 3. Okay. Now we have to put this g of x in f, right? So what is f of x? F of x is 2x. And what we have to find? F of g of x, i.e. in place of x, we have to write g of x. So I did the same, that in place of x, I wrote g of x. So here 2, again in place of x, what I have to write? G of x. Okay, so I write g of x. Now 2, what is g of x? We have to put the value of g of x now, which is x minus 3. So 2 multiply with x, 2x minus 2 into 3 is 6. So f of g of x is 2x minus 6. So this is how you evaluate f of g of x. So again, we have part B. So if there is some confusion in part A, let's do part B, and it is more clear to you. So in part 2, what we have to find? G of f of x. So again, we have to read it from right to left. So when you are reading it from right to left, the first thing occur is f of x. So we write f of x. So f of x is nothing but 2x. Okay. Then they are saying us that find g of f of x, i.e. we have to take g of x. So g of x is x minus 3. We have to find g of x. So g of f of x, right? G of f of x. So in place of x, we put f of x, right? In place of x, I write f of x because I have to find g of f of x. So here, instead of x, I have to write f of x minus 3. So f of x is 2x. So 2x minus 3 is the answer of gf of x. So actually, composition is really easy. Whenever you have two functions like this, f of x and g of x, and you have to find f of g of x or g of f of x, so you don't need to worry. Just take f of x and put, so which is 2x, and instead of x, put g of x. So it becomes this thing, g f of x, and here write g of x as well. And instead of now g of x, put the value of g of x, which is x minus 3. So 2x minus 6 is the same thing. So the example is complete, and this is the important example